Okay, so we don't know how to go from standard form to vertex form. So this is how we're going to do it. So let's say I have this equation. X squared plus 8x plus 10. When I was learning how to factor, when you guys learned how to factor, we used the algebra tiles and we made a rectangle out of them, right? Okay, so what we're gonna do though, because when we have vertex form, it's always parentheses squared, which means your length and your width are exactly the same. So that means instead of just making a rectangle, we have to force it to be a square. Does that make sense? Okay, so if I take my x squared and my 8x, if it has to be a square, I have to put 4 x's here and 4 x's there. Otherwise, it's not a square, right? And I want it to be a square. Then I had 10 ones. So here are my 10 ones. But what happened? I don't have enough. So I need to fill it in with some more squares, right? But if I just start adding things to my equation, does my equation stay the same? No, that makes it kind of change, right? So for every one that I add, what should I do outside my square? Okay, so let me ask you a question. If I added 1 and then subtracted 1, what am I really adding? 0. And if I add 0, does that change my equation? No. So I can add something as long as I balance it out by subtracting something on the outside. And my red squares mean to subtract. So I just added 1 and then I subtracted 1. So did I change the value of my equation? No, but I'm starting to fill in my square, right? Okay, so I'm going to add another 1. That means I have to subtract another 1. I'm getting closer. I have to add another 1, subtract another 1, add another 1, and then I got to balance it by subtracting it. Add 1 more, balance it by subtracting it. I'm almost done. There we go. All right, now do I have a square? Yes. Okay, so I just completed my square. There was a space open and I filled it in, I completed it. But for every one I filled it in with, I had to 0 that one out so that I didn't change my value of my equation. Does that make sense? Okay, so now let me ask you this. What is this dimension here? This is an x, and then 1, 2, 3, 4, so x plus 4. And it has to be the exact same here because it's a square. So my length and my width are the same. So this is x plus 4. So I could write this out as x plus 4 times x plus 4, or I could write it out as x plus 4 squared, right? So there we go, x plus 4 squared. And then what do I have on the outside here? 1, 2, 3, 4, 5, 6. So then I would, and these are negatives, so then I would say minus 6. And there's my vertex. And guess what this is called? Oh, vertex. Completing the square, because I built a square and I completed it. The name of your notes for today, yes. Okay, but I know you guys really don't like using algebra tiles a lot, right? So let's do it without algebra tiles. All right, so here's how we could do it without algebra tiles. Let's say I have this equation, x squared plus 10x plus 13. I know I need to make it a square, so I'm going to start by drawing my area model. And if I'm making it a square, my x squared is going to go down here, right? I have 10 x's. If I want to make it a square, they have to be evenly split. So what's half of 10? 5. Okay, so I'm going to do 5x here and 5x here. All right, now rather than drawing in 13 ones, I think it's a lot easier if I just take this 13 and just put it on the outside. And then if I want to complete my square, what has to go in here? If this is a 5 and this is a 5? 25. Because 5 times 5 is 25. Can I add 25 to my equation and keep it the same? No. What do I have to do to balance it out so that it doesn't change? Now I have to minus 25. Okay, so now let's fill out the outside. This is x and 5. So this is x plus 5 times x plus 5. So that's going to be x plus 5 squared. And then what is 13 minus 25?
Well, negative 12.
Negative 12. So then the outside of my vertex form would be minus 12. And that's how you go from standard form to vertex form. This is called completing the square. It is pretty easy, isn't it?